Good evening, guys. Can you hear me? Audible?
Yes, sir.
Hi, Chandana and Rakesh. I'll add you in the group. Okay. I'm sorry, really sorry. Yesterday I was too busy, right? I'll add you in the group.
Thank you.
So yesterday we have seen like how does the dynamic routing protocols works, and in the dynamic routing protocols we have about two types. What happened? So in the dynamic routing protocols we have two types. The types one is going to represent IGP and EGP, right? In this IGP we have two flavors. That one is the distance vector routing protocol and one is the link state routing protocol. In this distance vector routing protocol, we have two types. One is the RIP, and so three types: IGRP as well as EIGRP. And in the link state routing protocols, we have two types, that is the OSPF and ISS protocol. And in the EGP, we have a single type, that is the BGP. So IGP means what? Under the company network, if you have a routers over there, router 1, router 2, router 3, we are going to run the any EIGRP, any protocol of the IGP. And on the same company we have another routers over there, we are going to use the EHRP over, but between this two company we are going to use the BGP protocol. Okay, BGP means it's exterior gateway routing protocol. Okay, please allow the recording. Perfect. Now after that we have seen like how does the dynamic routing protocols works. Then for example R1 is there, and now we have R2, and 1.0.0.0.0 we have a 2.0.0.0. So if I'm going to run the X routing protocol, that is my dynamic. So what happened, R2 is going to send this information to the R1, and R1 is going to share the own information to the R2. So both the router has information about X 2.0.0.0 and X 1.0.0.0. So this is my dynamic information and learned by the dynamic routing protocols. Dynamic is what? Send me update. If anything is happening in your network, right? If anything changes happen in your network, maybe something goes down, something has arrived, just let me know also. For example, this guy has done, right? For example, somehow this interface goes down. R2 has a responsibility to inform to the R1, hey dude, I lose this information 2.0.0. Please remove from your routing table. This is how dynamic works. But in a static, what happened? The network exists or not. I have to put this route in my routing table. Right, then after that in the dynamic routing we have first discussed about the RIP protocol. That is, the RIP is the routing information protocol. Routing information means what? Information means IP. Information about the router. What is the information of the router? IP, a routing table, we can say a network ID. So router is going to share in the RIP. What happened in the RIP protocol? Router is going to share the own information. This information 12.1, 12.2, this is the 1.1. This is the information about the router. So router is going to share this information to the R2, and R2 is going to share this information to the R1. This is the routing information protocol that has an ADS of 120, and that works on the UDP protocol that has a source port number 520 and destination port number 520, right? Then we have discussed about like the metric of RIP is a hop count, and we have a maximum hop count is 15, right? 16 become the unreachable. So do you know what happening if any route goes down, right? The router is going to advertise the infinite metric. So this 16 is known as a infinite metric. Infinite metric means what? The route is not reachable. So if any router will receive a route, if any router will receive the route with the have a 16 hop count, what router will do now? Router is just going to assume that this route is unreachable, and I'll also need to remove this route from the routing table. Okay, and also we have seen like we can put the 25 routes in the single update packet, up to 25, not 20, up to 25 routes in the single update packet. So if you have thousands of the route information behind the R1, if you have thousands of the route information behind the R1, then you have to send the 40 update packet almost at every 30 seconds. And this is a periodic update. Periodic means what? At every 30 seconds of the cycle, I'm going to say the complete routing information. At every 30 seconds, I'm going to share the complete 1000 routes to you, 1000 routes to you, 1000 routes to you. That is the meaning of periodic update at a cycle. At a cycle, I'm going to set the complete routing information to you. Then we have seen that what is the difference between the version 1 and version 2. So let me write down the difference between this guy. We have version 1. Okay. Let me write down. This is version 1. So version 1 has a send update on broadcast. Send update, sorry, on broadcast address is 255.255.255.255. And then we have just give me 1 minute. Okay, so send me update on the broadcast at 255. This is a global broadcast address. Then it is classful out. Then it does not support the authentication. Okay, then after it does not support the summarization. After that, it does not send a submit mask information. In update packet. Perfect. This is the version 1 information we have. And if I'm going to talk about the version 2, we have a it send update. Multicast address is 9. Then it is classless and classful as well as. Then it does support authentication. Authentication can be have a two types. Text means a clear text or MD5. I'll let you know what is the meaning of text and MD5, don't worry. Then it does support the summarization. Then it does send in update packet. Clear? So this is my version 1 and version 2 difference. So we have discussed about what is the meaning of send update to broadcast. It means that if you have a look like this topology, this is my router number 1. This is my switch over there, a same broadcast domain. On the same broadcast domain, we have another router, and we have a PCs over there. We have some server, and then another. We have another switch over there, switch 2. Then we have another switch 3. So if the router number 1 is going to running the RIP protocol over there, this guy is run the RIP version 1. This guy is going to run the RIP version 1. And if we have some update 1.0.0.0.0, I need to send this update on which address? Broadcast. The source will become the MAC A. For example, this is the MAC of A, this interface. Broadcast address will be FFF, a layer 2 broadcast address. Source IP 1.1 for this guy. Destination IP, a broadcast. Then we have a RIP information, that is my 1.0.0.0.0. This information comes to the switch 2. What switch 2 will do now? Based on the layer 2 information, it flood this packet to this guy, this guy, this guy, even this guy, or this guy as well as. So whatever the user, for example, if you have 100 users behind the switch 3, if you have 100 users behind the switch 2, and if you have 100 users behind the switch 1, they all receive this broadcast message. So what is the problem with this guy? Just wastage of the bandwidth. At the same time, increase the process on switch, because the thing is that there is no any RIP protocol is running. There is no RIP router over there. There is no RIP router behind the switch 2 and switch 3. Why should I accept this packet? And this information will be flooded. Can you imagine that? This information will be flooded to each and every guy. What if you have a 20 switches in your network? In that 20 switches, this information will be flooded. And this is the reason behind it, that we are not going to use the broadcast. We are not going to use the version 1 in the market. Even we are not going to use the RIP in the market. But that's the problem in the version 1. So in case of the version 2, what happened? In a version 2, they will join the multicast group. I'll let you know how they will join the multicast group. Don't worry. So the multicast group number is this guy is 224.0.0.0.9. So if the router is going to running with the RIP protocol, if the router 2 is going to running with the RIP protocol, they will join the multicast group. Now whenever I'm going to send any update, the update will be, instead of the broadcast, we have a multicast address, and this multicast packet hits on this group, and in this group how many users are there? R1 and R2. Only this guy will receive the packet, not this guy, not this guy, not this guy, not even this guy, not even this guy. So this is the having the benefit of the multicast, right? Then after that, okay, let me configure this thing in the GNS. They'll also each and everything, and write down one more thing that about the RIP. RIP has a 2 packet types: request and response. Okay, already just okay. Classless. I'm not interested in this topology right now. I'll just take a 2 routers over there, R1 and R2. I'll just let you know what is the difference between the version 1 and version 2. And this is my a link between the R1 and R2, fast Ethernet 0/0, that is has connectivity with the fast Ethernet 0/0 of this way. Okay, and we have a LAN information that is, we can say that 1.0.0/8, and this guy is a 2.0.0/8. This is my LAN information behind the R2 as well. Come on, man. Okay, and this guy is a 12.1, and this guy is 12.2. Okay, putty, change reference. Oh, perfect. We have a 16. So let me define the IP address or basic IP addressing on the router number 1 and router number 2. Let us say router number 1. Config terminal. Interface 0/0. IP address 12.1/24. No shutdown. Interface loopback number 1. Loopback does not have a MAC address. Perfect. Router number 2. Interface 0/0. 12.2/24. No shutdown. Interface loopback number 1. IP address /8. Done. One fast Ethernet 0/0. I have defined this command of the 12.2 of this interface, and the loopback we have the LAN network of behind that, right? Now, next thing, enable the RIP. How do I enable the RIP? The first question is that first let's enable the version 1. I said router RIP. This command enable the RIP protocol on a router, right? Because of what I have said, router means which routing protocol you are going to enable. If you put the question mark on a router, you have a lots of protocol. Which protocol you are interested to run over there? I said I'm interested to run the RIP information, routing information protocol. After the putting enter, what happened? I will move in the routing configuration protocol information, right? And this command is just going to enable the RIP process on the router, right? After that, we need to tell this guy which version I'm interested. Version 1. So whatever the behavior of the version 1, class, pool, like it does not support the authentication, by putting this command, all this default configuration will be injected in the RIP process. What I'm saying that whatever the default configuration of the version 1, like a class, this is the class pool, they will send the broadcast address, they does not support the authentication, they does not send the subnet mask info. All this default configuration is will be set by putting this command. By default, this command will by I'm putting this command, what happened, all these features will be enabled in the RIP, all these features. Perfect. So next thing what I'm going to do that over there, I need to say that network, I need to say that network. Now question is what is the meaning of this command? So I have done with this command. What is the meaning of this command? Just going to enable the RIP process on the router. This command is just going to tell which version you are interested, version 1 or version 2. Now next statement is network. What is the meaning of network statement? First use, it advertises the network. Second use, it join the multicast group. Third thing, it enable the interface into particular routing protocol. So right now, just take a sniff of this link, and I'm just going to do on R1, R2 router. On R2, what I'm going to do, before I'm going to put in the network statement, I'll say do debug IP address. I need to see the background information, right? I just need to see the background information of the RIP protocol. I said at network 192.168.12.0, right? This interface, right? Now by putting this command, what happened on a R2 router? I'm present on R2 right now. On a R2 router, this 12.0 subnet is belong from which interface? Yes, give me a minute. Hello. Hey, hi. Yeah, hi. Azu. Just what happened? Tell me. Yeah, tell me. Yeah, I'll check it. Just give me the 1 hour right now. I'm having a batch right now. I'll just check it and let you know. Okay. Okay. So guys, what I said that when I put the network 12.0 statement, right? What is the use of this command? This command is just going to enable. First of all, it advertise the network. Okay. Second command said it join the multicast group. So right now we don't have any multicast because the version 1 will send the update on our broadcast, right? So it will not. It will skip this task right now. This task will be skipped, and then it do this thing, and then it enable the interface into the particular routing protocol. So this interface will be enabled in the particular routing protocol. Let's put the command over there and see. Now I'm going to send the RIP message. From which interface? A 0/0. From which interface? I'm sending the 0/0. I'm sending this update, right? But I told you that it enable the interface into the particular routing protocol. Whatever the R1 now, will R1 will understand this packet? It will never understand this packet because R2 is sending a request, right? From which interface? 0/0, because this 0/0 is live in this network statement 12.0. So let's do one thing. I'll say that network 2.0 as well as this statement, right? This is the loopback number 1. This loopback also will be enabled in the routing protocol. See, right now I'm sending the request on this guy. Now I'm sending the request on this interface. On which address? Broadcast, right? Will I be able to receive this packet, any packet? No. Why? What I told you that what is the meaning of protocol? If you're going to run with the RIP protocol over there, you have to be run the RIP over there, right? If I'm going to RIP over there, if I'm not going to RIP over there, what happened? Whatever packet this guy is sending to this guy R1, this interface is not a part of the RIP. How this guy will understand the RIP message? How this guy will understand this message? Is something like that, no? This is the one guy over there. This is another guy over there. This guy is sending us some information in the English language, right? And this guy know the Hindi. So will this guy is sending the hello? So this Hindi guy will never understand this message because they only know the Hindi. They don't know the English, right? So what they will do, they just silently listen this message and skip it. Same thing is happening over there. You have enabled the RIP protocol over there on this interface. This guy is sending the message to this guy, but R1 is just dropping it. I'm not able to understand. Please run me the RIP on. Please enable the RIP on my router as well as. Please enable the RIP on my router as well as. So what I'm going to do on this guy, I see that router RIP version number 1 network perfect. Now what is the next thing I'm going to do? I need to advertise my own network. That's my router RIP version 1, my LAN network 1.0.0.0. So right now this interface is enabled in the particular routing protocol, right? Let's enable this guy as well as loop back one. Perfect. Now what happened if I'm going to enable this guy in the RIP protocol? R1 will send this update to the R2 and R2 will send this update to the R1. Have a look. 12.1 I'm present on R2 router. I'm receiving this information. Let me copy this guy. See, this is the update that I'm receiving on R2 router. Perfect. I'm receiving this information from my neighbor 12.1 and this is the version 1 update. And I'm receiving this information on which interface? My local interface 0/0. And the update is, and in this update, what I told you that yesterday, that whenever the router RIP is going to send any information to the R2, whenever this guy will send any information to the R2, it is going to add some extra information. That extra information is known as a metric, and that metric is known as a hop count. And one router will behave like a one hop. So right now what happened, I'm receiving this information from my neighbor. I'm receiving this information on which interface? 0/0, that is my local interface. And this 1.0.0 update is there. He said that one hops away, right? And I'm going to add this route in my routing table by the next hop of this guy. RIP matrix is 80 is 120 and that has a matrix 1. And now this route will be added in my routing table. Okay, so don't worry about this thing. What is the meaning of this guy? I'll let you know in the switching class. This is just a timer of the router. This is just a timer of the router right now. So they have a look over there. What is my timer of right now? 8:30. So I received this information. The 8:26. Just a timer of this guy, nothing else. You can disable this thing as well as you just need to put the no timestamps over there. No timestamps for the command. So no service timestamp. I think so. Service timestamp. Okay. Now have a look. Debug IP. Now it will never send any timestamps over there. Just wait for some time. I'll let you know meaning of this command. Don't worry about that. So have a look. There's no timer over there. Okay. Now prove the first thing. What is saying? This guy is saying that it sent the packet on the broadcast address. Open the snip of this guy. Open the 12.1. Let me draw the packet. When R1 is going to send any information, when R1 is going to send any information, we have a source MAC. I'm just assuming that source MAC is A, destination MAC of FFF, that is my broadcast. Then we have a 0x800, that is my IPv4 information that type field. Then we have a 12.1 is my source. Destination is a global broadcast address. Then we have a RIP information. Sorry, UDP. UDP has a source port number 520, destination port number 520. Then after that we have a RIP information. In this RIP information we have a version 1, and then after that we have update of 1.0.0.0 slash, not slash it because it's a version 1, so we don't have any subnet mask information over there. So this update should be there.